Hi guys, so the subject of today's breakdown is going to be a send clock generator. And here's variations I have created for this breakdown. Just the basic ones. And I can enable disable glass support. I can disable vertex painting. It can also generate UVs. And here is also a vertex color transparency alpha. And this is a representation of the sand, which is a bunch of spheres. You can change the shape, like so. And the interesting part is that sand will deform also with the shape. So it also follows the shape. I can also control the thickness of the glass. And this sand options is specifically for sand. This option is basically a scatter node. The lower the value, the more spheres will appear. And I can also do something like this. Basically to remove spheres. And this is control the angle. You can also control the rotation. Also min and max scale of each sphere. Additionally, I also have an option to increase the number of poles. This is how I call them. I'm not sure how it's properly called. So I can change the radius, the amount of it, and also a profile of it. And I also have Unreal Materials to apply to the different parts of the geometry. Yeah. And so let's actually show you how I did it. And this is a whole node graph. This is to create sand, this is to create glass part, top and bottom rings. This is a poles, as I call them, and this is top parts of it. This is enabling and disabling glass support, generating low poly, UVs, global deforms, and cleaning geometry, and creating collision group for the Unreal Engine. And yeah, let's start with the glass. So glass shape itself starts with a line pointing into the default y direction, then I'm resampling it by giving more points, and the reason I have more points is to control the profile more precisely. So meaning if I don't have enough points, this is the result I will get. As you can see, it results into these jagged edges. But if I increase the amount of points, the shape becomes more smoother, if it makes sense. And under the sweep node, this is what drives this shape. I have changed the surface type to round tube, increase the columns amount, play around with the radius, exported the end caps group and changed the end cap to single polygon, as well as applied scale along the curve to create the custom shape of using this ramp profile, as you can see here. And after that, I have two separate streams to create top and bottom rings, and another stream for the glass itself. And for the glass part itself, I also added a thickness using poly extrude. And under the poly extrude, I'm also enabling the output back option, because without it, it will be like so. And everything else is pretty much by default, except the distance, which is controls the thickness amount. And after that, I'm creating a coloring, creating alpha using a simple vex. This means the attribute which is called alpha, and I'm creating a channel parameter, custom parameter to control the alpha, and I'm naming it as alpha, and in this way I can control the opacity basically. And creating a switch node to enable disable coloring. Speaking about coloring, I will come back to this at the end of the breakdown. And after that, I'm creating an Unreal material, and this is basically a material, which is a attribute create node, and the string value will be used to assign material directly inside of Unreal Engine through HDA by drag and dropping materials. To create the top and bottom rings, I have also blessed end caps, and the reason I need end caps is to make it a lot more procedural. So end caps comes from this sweep node, and then I'm using a for each loop to iterate over every single primitive. And the reason is because if not using for each loop, for example, if I want to scale this rings up, as I'm doing here, so if I want to scale it up, both of them will be scaling up, which is not what I wanted. I want to scale each of them independently from each other. And this is what for loop allows. So I'm enable a single pass option. So first of all, I'm scaling it up. Then I'm adding thickness to it. I'm also enabling an output back option. Then I'm doing a poly bevel. And under the poly bevel, I have created an exclusion, enabled an exclusion with this angle of normals. This is the distance, and I have changed the slide on ring edges to always, and stop loops to simultaneously. And this is to prevent something like this. So basically it will create a bevel until it hits another geometry, which in this case is this edge. But without it, it can go like so, which is not ideal for my case. And the same thing happens for the top part. I also forgot to mention that under the transform to scale up the shape, I have used I centered the pivot using these expressions, as far as I remember. This is how they're called, to center the X, Y, and Z pivot. And under the uniform scale, I have referenced radius from the glass shape, which is this one, under the sweep node. So copy parameter, then paste relative reference here. And additionally, I'm also using a reference from this poles transform, which I will show you later, and I'm referencing it here. And after that, I'm also enabling and disabling vertex painting and creating an Unreal material attribute. And this is how the top part is being done. And poles was created also using line and the sweep node. I also changed the surface type to round tube, play around with the columns and radius, also created a single polygon as an end cap type, and exporting an end cap group, and also I have enabled a custom shape profile, so I can control it later. And also, again, blasting end caps from the same sweep node, which comes from this glass shape. After that, I'm using split by normal by labs and specifying duration to -y. And the reason is because I want to place poles onto the bottom part of these rings. And after that, I'm resampling it, and this resample node will drive the amount of poles being generated. I'll show you just in a second. So under the resample, the only thing I'm changing is this length option. And then I'm scaling, and then I'm moving these poles by using a channel reference from the scale up node, which is this one. So I'm using this channel reference, like this parameter, sorry. So I'm copying parameter and then pasting relative reference and then negating 0.35. So, and after that, I get something like this. And if I merge it together to make it more clear to you, so this is the result. Let me actually show you with the glass. It will make more sense. If I remove this part, poles will be in the different place somewhere. So the reason I'm negating is to place poles like somewhere in the middle of this bottom ring. And this is how I can control the amount of poles by lowering the value under the resample node. So the higher the value, the less poles will appear. And also speaking about this scale up. So if I remove this channel reference, this is the result I will get. So basically I'm adding a glass radius on top of the, and if I remove this part, this is the result I will get. So basically it to control the gap between pole and the glass shape. And this is what this node does, and this reference. It controls the gap between glass and the pole, if it makes sense. And after that, I'm copying 2 points, each of the line. And by the way, I have changed the line direction to -1 because by default it will be like so. If the default direction will be to y, positive y, and the negative and the positive z will be like so, and the negative basically reverse. And then I'm also blasting end caps here on each pole, creating colors, creating Unreal material. And the reason I have deleted these end caps groups from each pole is because of creating this pole's top part, which, as I call it, so it doesn't intersect with this like top ring geometry, as you can see here. Let me actually show you. As you can see, it's now appears here if I don't delete the end caps. So this top part, again blasting end caps from each of these poles which is being generated, splitting by normals again, but in this case in the positive y direction. This is a negative, this is a positive y direction, and then I'm extracting centroid of each of the circles. And under extract centroid, I have changed the run over from pieces to primitives. You can also do a detail to extract the centroid of these 3 circles in this case. After that, I'm copying 2 points, this shape, and this shape also starts with a line in the positive y direction. I have increased the amount of points, and under the sweep node, again, surface type is surface shape is round tube. Play around with the columns and radius. Here I don't export end caps, and I have changed the end cap to single polygon. But I can do it like so actually. Oh, this is why I have enabled to close the top part. And even better actually would be to use, instead of this, would be to use the polyfill node. And under the polyfill node to create a triangle fan. I guess this will be better a little bit. Oh, in this case it wouldn't be any noticeable. So yeah, you can use polyfill instead. And so I'm copying points to those points from the extracted centroid. Then creating material, vertex material, and Unreal material. And this is how top part is done. Then I'm grouping this glass support, just in case. And under the switch node, I have decided to enable and disable glass support, so I can enable and disable it. And a 0 is no support, and 1 index is this support itself. And if I don't want to enable glass support, I just need to plug this null, and this will represent nothing, so no support will be displayed and rendered. So this is how you can enable and disable certain parts of the geometry with the switch node. And I have also exported a group for the glass, just in case I will need it later. And this is how the sand was done. So I'm using an object merge to reference glass geometry with this null. This is a path to the null, so you can drag and drop it here, or you can type it here, like so. And then I'm using a clip to separate only bottom part of the mesh. Then I'm polyfilling it. And the reason I need to close the mesh is because I will be using the points from volume. Because if I don't close the volume, it can't generate points inside of it. So this is how sand was created. So the peak here is used to make sure that the points is not directly on the surface, and it's kind of like moves them a little bit inwards into the volume surface. I'm not sure how to explain it better, but let me actually visualize it a little bit. So what I'm doing with this peak node is to move points somewhere inside of it. And under the points from volume, I have exposed this point separation, which is basically the amount of points to spawn. And I have played around with the jitter seed and jitter scale to randomize the points position to make it more random. And that's pretty much it. And then I'm also randomizing scale of each point by using a p-scale attribute. And min and max has been driven by the HDA parameters, as well as a global scale and global seed. Then I'm doing the same thing, but rotation. And the only thing I have changed from p-scale randomization is I changed the distribution to inside sphere. I choose it in this case, and the dimensions from the default, I'm not sure what was default, 3 to 4, because otherwise it won't work for the orient attribute. And then I'm clipping parts of the sand, and this is what clip does. So this is what this node controls. So and after that I'm copying to points a sphere, which is a very small sphere with this uniform scale, and set primitive type to polygon, and the frequency set to 1, and then I'm polar reduced it even more to get less points. So I have changed the percentage to keep to 60 from 100, and then copy it on every point. I have also tried to use pack and instance, which will be more efficient. But for some reason, Unreal didn't pick up the sand materials, the sand vertex color, which is I'm not really sure, but pack and instance will be a lot more efficient in terms of amount of primitives. So yeah. And what about this clip node is I have used a centroid and centroid expression here, and let me disable it. So this is a default values. So basically, I'm telling with this expression to center the pivot. So basically, I'm moving the pivot of the clip to the geometry, no matter how tall it be or whatever. So it will move the pivot to the center of the geometry, incoming geometry, which in this case is points here. And 0 means incoming geometry. And the only thing I have changed is under this y direction. So as you can see, it's somewhere down below the pivot. So I have added a 1. And you may ask why exactly 1? I'm not really sure also. This was a trial and error. This is pretty much all I can tell you. I actually went back and created another solution to create sand using VDB instead of particles, as you can see here. So I have now two options, VDB and particles. And I can control the amount of sand being added. And VDB, in my opinion, gives a lot more flexibility and speed, as well as look of the sand. And I can change the adaptivity size, which means reducing polygons, and can control the amplitude of the cutter. It's like cutter for the Boolean. So how I did it? I have added a null. I have created a VDB from polygons. After that, I have created a VDB SDF subtract, which is a VDB combine node. And this is like a Boolean node, but for VDBs. And before that, I have created a sphere. I have changed the uniform scale a little bit, but it could be like 1, but I decided to scale it down a little bit. Then I moved sphere on top of the clipped bottom part of the glass, which comes from here. And the way I have moved it on top of the bottom part of the glass is by using a bounding box expression. And so inside of bounding box expression, in this one, under the translate y, I have specified a null node, which is this one. Then I have specified that I want to move on top of the bounding box. So this is, just imagine this is a bounding box of this bottom glass, and dy max will tell Houdini to move sphere on top of this bounding box. And then I have added a channel reference on the top level of the HDA to move this sphere up and down, like in this direction, like to increase or decrease sand amount, which is this slider. Decrease sand amount or increase sand amount. But basically it moves a sphere up and down. And to make sure I have covered the entire radius of the this glass part, I have also used a bounding box expression for the x and z for the scale. And the only difference from the translate y is that I have used a dx size to match the entire size in the x direction of the glass geometry. And I have also added a +1 to make sure I have enough room for the Boolean. So it will cover a little bit more. So if I remove one, it will be like so, but it's the same thing here. And the same for the z-axis. And then I have used a mountain SOP to randomize the cut, this cut. And I have exposed element size, offset, noise type, amplitude, and into the HDA level. And then I also converted it to the VDB using VDB from polygons. And then VDB SDF to subtract to make a cut inside of this object. And then I convert it back to polygons. And I have also exposed adaptivity to control the amount of polygons. Adaptivity is basically like a poly reduce to reduce the poly count. And yeah, I can also do something like this, or maybe even like that, like copy. So copy voxel size from the cutter, from the sphere to this sphere. So it both of them have the same voxel size, and it will give a slightly better results, or maybe not. Let's see. Oh, it's really different. But we can do something like ×2. Oops, maybe it should divide by 4. Yeah, something like that, I guess. So if I change the voxel size here, it will update on both of the nodes. So yeah, it gives like a lot more interesting shapes, I would say. And yeah, let's move to the other part. And after that, I'm creating an attribute adjust color, and this is to create a vertex paint. And I have changed the operation to set initial, but default value will also work, but I have decided to use it. And I have also enabled color correction, so I can manipulate with the color data also inside of Unreal Engine. And also I have created a switch node to color with the noise. Instead of the constant color, I can color it with the noise itself. And I can change the noise type here and all of the other settings, as well as color correction. And also creating an Unreal material and grouping sand geometry. And this is pretty much how the whole geometry was created. And to create a low poly, you can use the poly reduce, but in this case, the value should be a lot larger, because it also affects the sand inside of it. But you can separate this poly reduce to affect everything but except this sand. And then I'm generating UVs. Again, iterating over all of the primitives in this case, but I will also separate it to not iterate over every single sphere, which is like this sand, to make it more faster. And after that, I'm creating a switch, another switch to global deformation. And I forgot to tell you that I have used unwrap with the default settings here. And under the band, the only thing I have changed is the up vector, because by default it was something different, something like this. It was pointing in a different direction, so I pressed B to cycle capture, and after I found the desired capture direction, I have played around with the settings. And I have exposed all of these parameters to the HDA level for taper, length scale, twist, and bend, as well as a taper profile shape. And the only thing which is important here is this capture length expression, which uses bounding box expression. And the bounding box expression means in this case is that it will capture the the height of the incoming geometry. So what I mean by that, if I disable this and leave it by default, as you can see, the default value is 1, and the capture length is not capturing the whole geometry here. But let me actually preview it. So it doesn't capture this part. But if I enable bounding box, it will capture the entire length of the object, including these parts. So this will be the bounding box. And that's pretty much it for the bending, for the deformation. And again, using a switch, which uses toggle to enable or disable deformation. So if you have a toggle under the HDA, you can copy parameter and paste the relative reference. So when the toggle will be won't be active, the value will be 0, and when it will be active, the value will be 1. And after that, I'm computing normals, scaling it down, cleaning geometry, but here I have left, I have deleted all of the attributes except of Unreal, which means Unreal material, color data, which is vertex color, UVs, normal, and alpha. And I have removed all of the groups. And right after that, I have created a collision group, which is called rendered collision geometry. And Houdini engine and Unreal engine will recognize it as collision geometry. And that's pretty much it for the creation of the sand clock geometry. And let me show you how the coloring was done. So this is another HDA. And this is not related to the coloring part. This is more like remission, edge damage, bending, subdivision, stuff like that. So here I have a base color, which is also an attribute adjust color. I have set operation to set initial. And before that, I'm also using a grid, which is a regular grid. I'm also grouping it to delete it later. And the reason I'm using this grid is to create an ambient occlusion for the mesh, because without the grid, it won't cast shadows onto the bottom of the geometry, if it makes sense. And I have also used an option to enable or disable preview of the ground plane. So I can preview the ground plane here. I can actually disable it, so it will make more sense. So as you can see, the difference here. And I can also remap the ambient occlusion here. I can change the color as well as the operation. So to create the ambient occlusion mask, I have used a physical ambient occlusion by Labs, and the mode is set to physical ambient occlusion, and the output attribute is AO mask. This is how I called it. And you need to play around with the settings to get the desired look. And after you create it and play around with the settings, you can remap this mask value using attribute adjust color by changing the pattern type to remap attribute. And then you need to specify the source attribute, which in this case is AO mask. I copy parameter and paste relative reference here. And you need to play around with this ramp slider to get the desired look you want. And the only thing to keep in mind is that you need to disable visualize output, because by default it will be like so, which is not what you want. And also important part here is that if you want to stack colors on top of each other, you need to set operation type to multiply. And this is the type I have used pretty much in every other node here. So I can enable curvature, edge color, and I also use the noise pattern here, which you can enable by using a noise pattern type here, and play around with the noise pattern settings here. And I also added a global color correction here. And the operation type is set to multiply, and the color is set to white. And this is a color correction here. And that's pretty much all for the coloring part, basically. So I can control, so I can add ambient occlusion to the poles also. And I can remap the ambient occlusion look of it. I can also add a color noise to the top parts, something like that, just to quickly show you what it does. Edge highlight. And sand also can be colored with a noise, as you can see here. And here how it would look like inside of Unreal Engine. So I can enable global deform here. I can enable or disable support. And I can also apply glass material directly inside of Unreal Engine. So I have a simple glass material. Oops, not this one. With the blend mode set to translucent, and lighting mode is set to surface translucency, or whatever it's called, translucency volume. And I expose this to a parameter, so you can right click and promote to parameter. And I have promote metallic roughness and opacity, and also base color. So, and then I created a material instance, and now I can drag and drop to the glass material attribute I have created inside of Unreal Engine, and this is a glass material. And now I can control the metalness, opacity, and roughness, as well as the color. And I can also apply colors to other parts of the geometry. And what about coloring? As you can see, the sand color has been changed. I can change it to something like this, as you can see here. can also make less sent present available or present. Not sure how to pronounce it, but I can rotate it. I can add less send, or more send, but it will be a lot slower. The same thing for the coloring. And yeah, I hope you found it useful. Hope it wasn't too complicated. And if it was complicated, please drop a comment in the comment section and I'll answer your question. And see you in the next video. Take care. Bye.